Hey, just a quick note before the video starts. I realized I spent the entire video calling these, I called solids of revolution. I called them volumes of revolution the entire video. So, whoops. Anyways, enjoy the video. Volumes of revolution are the shapes created when we rotate a function around an axis. This concept is interesting for about 3 minutes, and then it's dull and boring and stinky. So, what if we could rotate a function around a nonlinear axis? That certainly sounds cooler, but the question is vague, so I'll just show you my interpretation. Before we get into the specifics, I'm going to cheat a little. The goal of this experiment is to create a visualization of nonlinear rotations. This means that I will be approaching this from a programmer's perspective. Basically, I will cheat the system and have the computer do all the calculus for me. So, for normal volumes of rotation, my method of visualizing the shape is to create a bunch of very thin disks that, when put together, represent the rotation. It's technically only an approximation of the shape, but it's close enough. Alright, let's get into the actual math. To start, I set a few ground rules that my interpretation must meet. First, the rotating must be unconstrained to the x or y axis, so you can have angled rotations. Second, I want each rotation to be centered around the axis function. And last, I want the interpretation to be able to create normal volumes of revolution as well, so there shouldn't be any funkiness there. Alright, here's my first approach. We have two functions, r and a. Function a is the axis of rotation, while function r is the one we rotate around function a. Pretty simple. Now we find the y-axis distance between each function at a given x value, and then we use that as the radius for each disk along the interval. Nice. Except this doesn't meet our first requirement, that the rotating must be unconstrained to the x or y-axis. In this case, all of the disks are perpendicular to the x-axis, which means the shapes we create are very boring. Upon seeing this issue, I went through a bunch of ideas, until settling upon a final approach. In this approach, everything is the same as before, except for the rotations of the disks. Each disk's rotation is set perpendicular to the tangent line of the axis function at a given x value. With this, our disks are no longer constrained to an axis, and we can make some pretty cool shapes. A side note about this method is that because we rotate the disks, they can actually overlap, and you can have double volumes. So it's not really perfect, but I don't know, I think it looks pretty cool anyways. Anyways, I experimented a bit with the different shapes you can make. First, we'll try a normal volume of revolution, like rotating y equals x squared around y equals 0. This works as a normal volume of revolution would. We can do a lot cooler stuff with it though. I'm urging everyone to go ahead and try this program out because it's pretty cool. You can make some interesting stuff. There's not really a tutorial on how to use the program. It's pretty self-explanatory. You just input a interval and then a function for your axis and a function for your rotation, and then you click start, and you can view the shape in 3D space as well. It's pretty cool, and I hope you guys enjoy.